Hello and welcome to Wednesday's edition of Cracking the Cryptic, where today we've got a puzzle for you by Lizzie01. And rather beautifully, this is a tribute to Cracking the Cryptic. Look, you can see if you highlight the cages on the left-hand side of the grid, C, T, C. So yeah, I'm delighted to see this. Now, what I'm less delighted about is the fact that this puzzle has laid waste to our testers. Two of them got absolutely nowhere with it. Now, it has been solved by one of them, and apparently it is brilliant, but this has come very much with a health warning for me. I've been told to allow a long time for this video and to expect perhaps to get completely stuck. And if I get completely stuck, I'm afraid you'll never see the video, but hopefully you are watching this, and hopefully I will have managed to make my way through it. And yeah, I'll read you the rules in just a moment. The big announcement I've got today, well, I've got two big announcements actually. In fact, I should have got a copy of the book. There is now a physical copy of the book, our book, which actually exists, and which is incredibly exciting. It's been a long time coming. We've really gone to town with the artwork, with the setting, with the paper, and we're doing our very best to make sure it's the absolute tip-top quality product you'd expect from us, and it's really close now. So if you I tweeted about it yesterday with some real pictures, so if you follow us on Twitter, which is @CrypticCracking, you'll be able to see those. And yeah, very exciting it is indeed. And if you've not got a copy of the book yet, you can still get it actually over on the Kickstarter page, which is where we launched the book in the first place all those months ago. Now, apart from that, the other thing to mention, the other reason to follow us on Twitter, is that I am intending to try my first live stream of The Witness tomorrow night. So that's Thursday night. I'm not sure exactly what time it will be, probably around 10 o'clock in the evening UK time, to try and cater for anybody who might want to watch in the Americas. Yeah, so wish me luck with that in many ways. Firstly, from a technological perspective. Secondly, from just a gameplay perspective. Thirdly, from a seasickness perspective, because when I have tried to play The Witness the other night, I did get motion sickness quite badly. I've now adjusted the settings in the game a little bit in response to some feedback we got, and I'm hoping it'll be good enough that I'll be able to do a stream for an hour or two. So yeah, look out for that if you have any interest in watching me make a fool of myself in front of a computer game, and a lot of people, hopefully. Anyway, let's get back to this. What are the rules? We have got normal Sudoku rules apply. Along thermometers, digits must increase from the bulb end. Okay, I'm just pausing there because I've noticed the thermometers are blue today. Oh, right, okay, I see why. I think it's only because it's this arrow, isn't it? Presumably, okay. So if we'd done a thermometer here in our normal grey colour, I guess this arrow would have been less visible. So perhaps that's why we've got blue thermometers. I don't know. Anyway, digits along an arrow sum to the digit in that arrow's circle. So that's normal arrow rules. So that means whatever those three cells add up to. Let's say it was, I don't know, that's not going to work. I've got to change the colour. Let's say it was 2, 1 and 5. That would add up to 8, and therefore we would put 8 in the circle. That's how arrows work. Presumably thermometers are fairly clear. You start with a low number in the bulb, and then you increase thereafter. So something like that would be a valid way of filling the thermometer. Anything else? Yeah. In cages, digits must sum to the small clue in the top left corner of the cage. Digits cannot repeat within a cage. So normal killer Sudoku rules. So what does that mean? It means that those cells there, those 7 cells in the bottom C, have to add up to 36. If you think about the secret, that tells us something about that cage at least. So do have a go. The way to play is to click the link under the video. Now I get to play Let's Get Cracking. Let's get cracking. So where shall we start? Have we got any easy wins? We've obviously got some enormous cages on the left side. Alright, okay, so maybe the secret is where we start. Because, what is the secret? Well, the secret, of course, is that any complete box, any complete row, or any complete column of a Sudoku will have all of the digits from 1 to 9 in it. If you add up the digits 1 to 9, you get 45. So, we can deduce the value of this domino. because if this cage adds up to 35, but the whole box adds up to 45, those two squares add up to 10, which, yeah, okay, well, this is a 3-cell arrow as well. So what's the minimum or value of this cell? If we put 1, 2, and 3 into those 3 squares, this would be a 6. So it's got to be at least a 6. And this square's got to therefore be the complement of this cell in order to make sure both cells together add up to 10. Right, okay, well we can get rid of 6 from here straight away, because if we go 6, we have to go 4 to make the box add up to the right total, but a 6 arrow must be a 1, 2, 3 arrow, so that's immediately wrong, and we can get rid of it. So that's definitely not a 6, and that's definitely not a 4. Yeah, okay, I can get rid of 7 as well. If this is 7, this has to be 3, but a 7 arrow would have to be 1, 2, 4, so that also doesn't work. Oh, here we go, we're okay here. So now, okay, that's yeah, okay, we can't go any further with eliminations, but we have at least limited the options a little bit so far as this domino is concerned. This looks like a classic disambiguating thermometer to me. I'm not going to pay that any attention. Let's have a look at the 31 cage, maybe the T. That's less good, I think, because what that's telling us is that these two dominoes here have to sum up to 14, i.e. 45 minus 31. Unless there's a way of knowing that there's no 1 in those 4 cells, I don't see how we use that. No. Okay, let's have a look at this one. A 36 cage. So, see, this one doesn't sit all within box 7 either. This one's a bit trickier. All I can really tell you about this one is that it's missing 2 digits that add up to 9, because we know that a 9-cell cage would contain all of the digits 1 to 9 and would add up to 45. So a 7-cell cage must be missing 2 digits that add up to 45 minus 36, or 9. So we know there's a 9 in this cage. There we go. That's the deduction we can make. Which is a fat lot of use. Okay, let's have a look at the arrows, I think. It looks like there's a lot of real estate in column 7. And there's a sort of syzygy of circles in column 6. So I think column 6 and 7 we might find some joy. I have to say I'm not seeing much else at all. This arrow is a bit of a tricky one, isn't it? Because although it's a 3-cell arrow, so we might immediately think we could write a 6, 7, 8, 9 option into this cell. That's not true, because these digits don't all have to be different. If this was a 1 and this was a 1 and a 2, this arrow could be as low as 4, which means I'm not even prepared to pencil mark it, to be honest, because I don't want to put 6 different options into the cell. This one's better though. These 3 squares must be different digits. Oh. Yeah, okay, I've just noticed something else, which is not related to column 7. It's related to box 3. I've got a 3-cell arrow and a 2-cell arrow in... Yeah, okay, this is interesting, in box 3. So what's the minimum I could put into those arrow cells? Well, it's going to be 1, 2, 3, 4, and 5, which is 15, which means these 2 squares must add up to at least 15, and therefore in each case they must be at least 6. If you try and put 5 into one of them, you'll have to put 10 into the other one. I'm not sure if I can go further than that. Let's maybe have a look. I can see we've got... See, I'm not sure whether I'm meant to count this one as well. I think maybe not. Let's start off with just noticing the 15 trick again in column 7. These 5 arrow cells here have got to be a minimum of 15 again, 1, 2, 3, 4, 5, which means these 2 moons have to be at least equal to 15 when we add them up, and therefore this square's got to be a 6, 7, 8, or 9. Okay, the 14 cage has to be either 5/9 or 6/8. I'm just wondering if I can collect enough high digits somehow pointing at each other to get some traction here. I'm not sure. Let's 21, 22. So if this was 17, this would still have to equal 5. Yeah. So what I was wondering here is what would happen if I added in this cell to the sort of congregation that we've got going on arrows in column 7. So those 6 cells now could be a minimum of 1, 2, 3, 4, 5 and 6, which is 21. But we've got an extra arrow cell there. Let's make this the lowest it can be, which it could well be because it's the bulb of a thermo. So the absolute minimum I can make these 7 cells is 21 from column 7 plus 1 from column 8. So that's 22. That means these 3 squares here are a minimum of 22. But as those 2 squares could be as high as 17, that means this has to be at least 5. Don't really see how that's useful. Let's try something else then, although I'm running out of ideas here at a rapid pace. This one is utterly useless, surely. It's just a 2-cell arrow. The fact its circle is in the syzygy is only useful if I know what those 3 squares are. If these were a triple, then perhaps this would be limited. Why are those a triple? They're just not, are they? There's just no way they are a triple. I have a horrible feeling I'm missing some implication of this column 7 alignment. I mean, there is a bit of restriction in the sense that these cells are a minimum of 21, but they can't be greater than 23, because whatever we make these, if we make them 23, we've still got to add at least 1 in here, that's 24, and we can't make them bigger than that because these 3 squares would have a maximum value of 24 if we made them 7, 8 and 9. So there is a real restriction on those 6 cells in the sense they either add up to 21, 22 or 23. Now I'm wondering if maybe it's a high digit restriction. Yeah, okay. Okay, that is not a silly thought I've just had. Right, I probably should have thought of this earlier, but what is the thing I do know about 3 cells that have to add up to at least 22? They must have a 9 in them. And that is potentially interesting, because if one of those 3 squares must be a 9, the thing that got me thinking about this was actually looking at column 7 and asking whether 9 was in column 7, because I know it can't go on an arrow. And look, it's in the same cells. That is interesting. So perhaps we've got to look for the positions of 9s. What about column 9? Oh, no. Actually, no. That is useless. Okay. Sorry. So... do we have to have a 9 in the 31 cage? Oh yes, we do, actually. That's interesting. Right, right now this has definitely got my attention now, because we said that those 4 squares added up to 14. Well, if one of them's a 9, the other 3 squares would have to add up to 5, but they've all got to be different digits. That will not work. 1 plus 2 plus 3 is 6. So there is a 9 in a 5-cell 31 cage, which is not something I'd ever really focused on in my life, but there is. Whoa, okay. Okay, and a 7-cell 36 cage also, it's missing 2 digits that sum to 9. So it's not missing 9 and 0, so it has a 9 in it, so there is a 9 in there. What does that mean? So that means in the purple squares, I've got to put 4 9s. And there's sort of 5... I want to say there's 5 different units here. There's sort of this bit, this domino, this domino, this domino, and these 2 cages. I feel like this is restricted, but maybe I'm misleading myself. I've got to put 4 9s into these. So if I put, I can put 1 9 into this triple, 1 9 into this triple. Yeah, it's nonsense what I'm saying about 5 units. There are really only 4 units. There's 1 there, 2 there, 3 here, 4 there. So these squares can only take 2 9s. Ah, yeah, they can only take 2 9s, but they must take 2 9s as well. Oh, I see. Right, I've understood it. Sorry. I've understood it now, I think. This is really, really clever stuff. This might even have a name, this pattern, and I'm sorry, I just don't know what it is. But what I've finally realised is that there must be a 9 in those cells. How have I realised that? Well, I was look at the horizontal strings here. We've got 3 horizontal strings in the 31 cage and the 36 cages. What would happen if we had 2 9s in these 3 strings? Well, if we did that, we would break the fact that we have to have 2 9s in these strings. Because, for example, if I put a 9 in one of those, 9 in one of these squares and a 9 in one of those squares, now I can't put 9s there or there, but I know that these 6 cells have 2 9s in them. So that's not right. Is there a more elegant way of expressing that? Probably is the answer. Sorry if you're getting annoyed with me about this. But if I can't put 2 9s in those 9 cells there, and I can't, then I must only put 1 9 in those squares. And that means I've sort of got an extra constraint relating to those 3 squares. These 3 squares here must contain a 9. I've got no idea how I'm going to pencil mark that. But I'll just do it like that just for the moment, because it's obviously affecting this square. You can't have... I think that's right, isn't it? I mean, it's a strange pattern, but it feels correct. There's no way that those 9 cells there can contain 2 9s, because if they do, I've broken these 6 cells. So these have a maximum of 1 9 in them, which means there's a minimum of 1 9 in those 3 squares, and in fact those 3 squares can only have 1 9 in them because they're all in the same column of the Sudoku. So that square is not a 9, and that's an 8. And that's a 2, and I have some digits at last. Good grief, and that's a 1 5 pair to complete my 8 arrow. That's just, I mean, that's startlingly brilliant. If that's what you're meant to do, to figure out that there's a relationship between 9s in these purple cells, I'm almost lost for words at that. That is so clever. Now, the other thing I suppose I should think about is, does this affect other things? So if I know that there's a 9 in one of those 3 squares, I know those aren't 9s for sure. In fact, I know a lot more about 9s than I'm letting on here, don't I? This square, and this square can't be 9s either. Because if I try and put a 9 here, I'm removing my ability to put a 9 in one of those 3 squares, which I cannot do. So we can remove 9s. Those are not possible positions for 9s anymore. So maybe I'll use a different colour, because then I can colour those as well. These can't be 9s. If there's a 9 in one of these 3 squares, there's no 9 in any green cell. Now what I haven't got my head round now, I've got to put a 9 now in one of these. Yeah, so I've got oh, this is so strange. I've got a weird disconnected swordfish, haven't I? By which I mean that because one of these outlined in blue purple cells must contain a 9, and I know that there are 2 9s also in this collection of cells, then I can't put any more 9s in row 4, in row 7, or row 9, because if I did, we know that these outlined cells contain exactly 3 9s. How many 9s are there in row 4, row 7 and row 9 of a correctly completed CTC tribute puzzle by Lizzie01? There are only 3 9s. There must be 1 9 in each row. So there are no more 9s in any other cells in these rows, which means there's no 9s in any of those positions, these positions, those positions. No 9s is my contention, which means that is not a 9. And if that's not a 9, it means that square is not a 6, because we know those 2 squares add up to 15 because of box 3. Wow. Wow. That is a weirdness. That pattern there is a weirdness. Well done, Lizzie. You've discovered a weirdness. Now, I'm wondering now about that square, actually, because it can't be a 2, 1, or... No, that's a silly thing to worry about. Sorry. I was thinking that this might be restricted by the fact that we've actually got some digits in row 2, but you can see if this is an 8, this square could actually be as big as 7. So it's got a lot of options. Well, maybe not a lot, but it's got to be 3, 4... 6 or 7, so it does have a lot. Oh dear. Hang on. I got rid of a 9 here, which got rid of a 6 here. Which means this can... We know those 2 have to add up to 15. No, that doesn't get rid of anything, does it? Bobbins. What am I meant to do now, then? Surely I've got to use this funny 9s position. I've got rid of a 9 from here. I've got rid of a 9 from the 10 cage. I wasn't really thinking of putting a 9 in the 10 cage. Why does that matter? It means there's no 1 in the 10 cage. Does that matter? This is a thermo. Oh, right. Hang on a minute. Yeah, okay. I think I have found something here. Let's look at these 5 cells, which we know add up to those 2 cells. So we know that these 2 cells are a maximum of 9 and 8, which is 17. Now, does that mean that one of these 5 cells is a 1? Well, yes, it does, because 2, 3, 4, 5, 6 add to 20, which I simply cannot make those add up to 20. So there's definitely a 1 in one of those 5 cells. And that means this is the point of the swordfish. Because you can't have a 9 in the 10 cage, you can't have a 1 in the 10 cage, you can't have a 1 halfway along a thermometer because you'd have to put 0 in the bulb or a negative number. So those squares can't be 1. These can't be 1 because of the 1 that exists on the arrows up there. So there's a 1 in one of those 2 squares. Which maybe doesn't do much. Which means that there is a 1 in one of those 4 squares. And in this box there's a 1. There's not a 1 there because we know there's a 1 in one of those. So there's a 1 in one of 4 squares in box 6. Oh my goodness me. Oh, good grief. Oh, I've got it. I've seen the light. I have seen the light. Right. Okay. This is just ridiculously clever. This puzzle is extraordinary. Now, what I did not realise before I started looking at 1s in this box is that 1s are restricted in box 5 in a way that I'd never even looked at. Look, we've got a 1-5 pair here. Now look at box 8. And where does the 1 go in box 8? The answer to that is I have not got a Scooby-Doo, except it's definitely not going to be in a circle. If you put a 1 here, you've got to put 1 and 0 there. That's not going to work. So the 1 is in one of a multitude of cells, but crucially, it's definitely not in column 6. And it's definitely not in column 6 in box 2. So the 1 in column 6 is in one of those 2 squares. Why is that important? Well, I've just shown that there's a 1 in one of those squares in box 6 because of this pencil mark. So now the question we can switch to is where does the 1 go in row 4? Because it's not there and it's not there. So it's in there. And it's in a 31 cage of size 5. So if you've put a 1 into a 5-cell 31 cage, what are the other 4 digits? Well, they are 6, 7, 8 and 9 by force. That's the only way you can get to 30. So this is a 1, 6, 7, 8, 9, 31 cage. We've got an 8 here. So now we've got a horizontal 8, which means I've not got 8s in those squares anymore. Oh, and so that's a 9. This is just a beautiful puzzle. I am blown away by this. I don't know, I didn't actually look at this, whether Lizzie has featured on the channel before. But if she's been making puzzles like this, these need to be seen. This is just unbelievable. Look, we've got 9, well, we've got those 2 squares have to add up to at least 15 because of box 3. So this can't be a 7 and a 6. That only adds up to 13. We're going to need a 9. Which means those 2 aren't 9s. Those aren't 9s. So there's definitely a vertical... okay. So now in my 31 cage, I've got a vertical 9 in these 2 squares here. So that's not a 9 anymore. And that means that we can change its colour to green and remove the pencil mark. Right, and now I've got a 1, 6, 7, 8 quadruple in row 4. So the other squares here, that can't be a 9 anymore. The other squares have got to be the other digits. That's 2, 3, 4 and 5. Which... so maybe this is where we look next. Because I'm now noticing these 3 squares, which originally I thought could be very low numbers, now can't be. This square can't be a 1 or a 2. So that's at least a 3. And this square can't be a 1 because of this. So the minimum value for those two squares is a 2 and a 3. And the minimum value of that is a 3. So this is an 8 or a 9. And this can't be a 5, I don't think, because 5 plus 2 would make plus 3 is 10. So this is 2, 3 or 4. This square is 2, 3 or 4 as well. 4 and 2 is possible with a 3 here. That can be a 4, but it can't be a 5. So and this isn't a triple because of course this digit could repeat in those two digits, so we've got to be a bit careful with that. So this is 8 or 9. I don't know what we do with that. This has come down to being 6 or 7, so that can no longer be 7 anymore. So this square is really restricted now. If this is 6, this has to be 2. And if this is 7, we get to say bobbins, because that could be 3, 4 or 1. Oh, good grief. Oh, it's not, no, it can't be 1, because we have a 1 down there. So 2, 3 or 4 for this cell. These two squares, don't think they're restricted at all. Right, okay, so where do we look next? That is the question. Maybe these squares look, because we've got this quintuple. So these squares, oh yeah, okay, look, I've got to put a 2 on this side of box 4, which means I've got to put a 2 in one of those squares in the 36 gauge, which means there is now definitely a 7 in the 36 gauge, because we know it's missing 2 digits that sum to 9. So if it's got a 2 in it, it must have a 7 in it. Don't think that matters though. I'm actually wondering if that digit's restricted, because presumably in order to make... I can definitely get rid of 2 from this square, because I'm thinking, even if this... Well, in fact, that's interesting. In fact, yes, here's some logic. That can't be a 6. If that's a 6, those squares there have to be a 1, 2, 3, 4, 5 quintuple, and that square would have no value. So that is not a 6. So this domino either adds up to 7 or 8. And if that was 16, these would be 1, 2, 3, 4, 6, and that would be a 5. And if this is 17, if this was 17, it could be 1, 2, 3, 4, 7. Or it could be 1, 2, 3, 5, 6. Oh, you rotten thing. So I can eliminate 2 and 3, definitely, but I can't eliminate the 4. Because there is the smallest chance, look, which means it's probably true, that this is 8, and this triple, or quintuple, I should say, is 1, 2, 3, 5, 6, which would allow this to be a 4. It's the only way that could be a 4. So, sorry, yeah, that's not going to work. Has that put any pressure on this digit? No, because this, I mean, these two being high is not that surprising. This can still be as low as it likes to be. Unless getting rid of 1, 2, 3, 5, 6, 4. So if these were 1, 2, 3, 4, 5, 6, these would be 7, 8, 9. 2, 3, 4, 5, 6. These would be 7, 8, 9. That would have to be 7. This would have to be 8, and that would have to be 8 as well. That doesn't work. Hang on. There is something going on in column 7 here, because I don't think this can be a 1, 2, 3, 4, 5, 6 sextuplet. I'm going to think about this the other way, I think. I'm having a difficulty, or it's getting very complicated thinking about it the first way. What do we know those squares add up to? They're a minimum of 21 and a maximum of 23, because I need to add that digit in and keep these down to a maximum of 24. Wow, this is complicated. So if I can't put 4 into any of those squares, what do I get as the minimum value? I must get the triangular number for 7, which is 28, minus 4, which is 24. Right, that doesn't work. Okay, so you can't do that. If there is no 4 in the outlined in blue cells, they have a minimum value of 24, which is impossible, because once we add in the 7th cell here, that will be at least 25, and these 3 squares cannot add up to 25 because of the syzygy. Ta-da! So that's not a 4. We need to put 4 on a line. That's a 5. Which probably doesn't do very much, but let's see. So now I can't put 5 on the arrows. So the minimum value I can put on the arrows is 1, 2, 3, 4, which is 10, 6, 7, which is 23, which is forced. That's absolutely forced, because if we had more than 23, we're going to have these adding up to more than 24. So these have to be kept down to 1, 2, 3, 4, 6, 7 somehow. And that means these 2 squares are an 8, 9 pair. It means this square is a 1 by force, because we need to add the 1 to the 23 to make these 24. Now that means this square is a 7 or an 8. I've now got an x-wing on 8s in these 2 squares, so there's no 8s in any of those squares or that square. So there's an 8 in one of 2 places in box 7. The simple way of seeing that is just to ask where 8 goes in row 8. Can't go there, can't go there. So it must be in one of those 3 squares, and this square takes care of that one. Yes, now I know what's missing from the 36 cage, which is an 8, because we can't put an 8 in it, and therefore a 1. There is no 1 in this cage. And there's a 1 here, so there's no 1 in those squares. There's a 1 vertical in those squares. There's no 1 here, apart from me and the Sudoku. I'm awarding the Sudoku personality, because this Sudoku has got personality in spades. I've met many people in my life who have less personality than this Sudoku. Now, hang on, what does that mean? So now I've got my quadruple along here, and I know that 8 belongs there. I haven't actually, I don't think, impacted any of the important cells though. This is a 7 or an 8, so this is restricted. This has got to either be 6 or 7. This is a 7 or an 8, which doesn't actually seem to restrict that at all. And this, well, 9 can never contain a 7. But the 7 can still go here, so I can't assume the 7's there. So what about the 6? Oh, the 6 could go down here, all the there. 6, 7. Oh, good grief. Right. That's not a 6. This is not a 6, because you can't make the arrows work because of this 5. This is ridiculous. This is one of the great puzzles that we've ever seen. And it's a tribute to us, which is rather humbling, frankly. Why can't this be a 6? Well, what are we going to put on those 2 squares? Well, this will have to be a 4, because it's the only option it's got, because of these two squares. Yeah, the simple way to see it is that this 1-5 pair is ruling out a 1 or a 5 from this square. So this domino must be a 2-4 domino, and this has to be the 4. Now that means this domino needs to be a 1-5 pair, but it can't be. So this is just not 6, and if that's not 6, I think that means it's 7. And if that's 7, that's not 6, because this can't be 1. So this has become a 3-4 pair, which means that's not a 3-4 pair. So my 9 is now 1, 2, 6, and this square is forced to be a 6 by Sudoku. This is not 1, 2, or 6, or 7. So this is a 7. This is a 7, this is an 8, and it's all, and this is an 8, and this is a 9, and it's all working. Now those aren't 9s anymore. So the only, out of the weird sort of disconnected swordfish logic, we've got a 9 in there and a 9 in one of those two. Oh gosh, look, now I've got a 9 here. I could have done the 14 cage. That's got to be 6, 8. That means that's not a 6. Now this has to be, I think that has to be a 6, 8 pair. And you can see that you can't put 8 on a 7 arrow, so that's going to be 6, that's going to be 1, that's going to be 8. Yes, that's working, it's working. This has got to be 9, this has got to be 2. This 9 is fixing a 9 here, because we knew that one of those two squares had to be a 9. In fact, I could have changed those, couldn't I, a while ago, back to green, because of this 9 here. That's now a 7. Whoopsie. So there's no 7s in those squares. These are a 1, 6, 8 triple. Let's just get rid of some of the corner pencil marking, just to make it clear what's going on. We've got a 2 here, so that's getting rid of... Ooh. No, I was wondering whether that was going to fix my arrow, but I can still have a 2 here perhaps. So maybe I don't get to resolve that. Okay, right, let's pause for breath. Let's take stock. What have we got now? We have got... I've got a 9-8 pair there in those two squares by Sudoku, which means those two are a 5-7 pair, and I know the order. So that's a 5, that's a 7. So we need 3s, 4s, and 9. Ah, so that's a 3 or a 4, because it can't be a 9, and that must be a 9 by Sudoku. And I still don't actually know. I don't think I do know, do I? Where the 9 goes in this, well, in this domino. It could be here, but I think it could still be here if this is a 9. I have a horrible feeling I'm making a fool of myself by saying that, but I can't see immediately why that's not the case. Oh, look, I've got a 3-4 pair in row 5. Okay, let's look at this then. So I've not placed 2s and 5s. So this square is definitely not a 1. So I can place the 1, and this is a 2 or a 5, and this is a 2 or a 5. What about this arrow then? Yeah, this is a little bit restricted because it can't have a 1 on it. So it's a minimum of 2 plus 3, which means this square is at least a 5, and it can't be a 7, 8, or a 9. So I think this gets resolved down to 5 or 6. Now that means it's definitely got a 2 on it. So there's definitely a 2 on this arrow, so this is not a 2. Oh, look, my 10 cage now is very useful. It's got to be a 6, 4. Those squares, oh, hang on, let's just check what's going on here then. That 4 is nice, yeah, okay, 4s and 3s get placed. I still need to put a 3 in column 8, this must be here. And the thermo is going to tell me the order of those two digits, which are 2 and 5. That's not a 2 anymore. Okay, so I get the 2 in this box. I've got to remember, I've got 1s and 8s. Is there something I can do? Yes, here's something. Use this 1 and note that there's none of those squares can be a 1 in this box, so the 1 must be those 2 squares. And that means that that square is not a 1. So that's a 5, that's a 1. Now where does 5 go in box 5? I think here. That means this square has become a 2. I feel like I've done an awful lot of 2-age in this grid, but I still no, I have done a fair bit, but it's still not resolved. This 5 is giving me a 6 here. So this is now a 2-4 pair. That 2-4 pair goes with a 3-4 pair, and we now know there's a 4 in one of those 3 squares, which is pretty hopeless because we already knew that if we looked at those squares. So this is a 2-3-4 triple. These squares are 3s, 4s, and 5s. Oh, is that true? I think it is true, and that gives me a triple there. So this square has become a 2, which is very irritating because it means this still has the ability to be an 8. But the 2 does at least give me the 2 and the 4, and the 4 and the 3. So I shouldn't cry about it too much. And the 3 and the 1, in fact, and the 1 over here. And those squares have got to be a 5-9 pair. Ah, and I know the order. So this is 9 after all this, which means that's 9, that's 8, this is 5, this is 8, that's 8, that's 6. In order to make this add up, that's going to have to be a 3. Fixing the 3 and the 4, those squares have got to be a 4-5 pair. This has got to be a 7. Now I still need to put 9 and 6 into those 2 squares. Oh, I had a horrible fear I was going to get a deadly pattern, but no, there is a difference between a 9-8 pair and a 6-9 pair. But that square is now known. That is a 7. 7 is in one of those 2 squares. We must be getting closer to a solution. Yeah, we can do that square. This is a 3. We can do this square. That's a 7. So that means we get the 7 in the top box. We're left with 4, 5, and 6 into these squares. Yeah, I see. And now we can use this 5 look to tell us where the 5 goes. We can't repeat 5 in a cage. So that's a 5, that's a 5, that's a 4. The 4, 6 must be resolved. I don't know. I should get rid of the fact that that's not a 9 though. That's also not a 9. Otherwise people will get cross with me. Let's get rid of all the non-9 cells. There's another one there, look. Trying to hide away. I've got an 8 here, so this is a 6. That's a 1. That's an 8. So we now got 1s, 4s, and 6s into that column, I think, to complete it. But we don't seem to know enough about... Oh, we know this is not a 6, because that can't be a 7, 8, or a 9, and the thermo would be broken. This 8 is giving me the 8 and the 9 over there. That's probably been around for a while. Therefore, this is not a 6, and we get the 6. That's a 6. That's a 4. I've got a 1-4 pair here. I still need to put 5 and 6 into those squares, which I can now do. The 6 doesn't resolve this thermo. This 4, though, is useful. So that's a 4, that's a 1. That's a 1, that's a 2. This should be a 3, that's a 4, that's a 2. I've nearly finished. That's a 3. It's worked. Oh, yes. That is just... Well, that's a genius puzzle, Lizzie. That is a genius puzzle. My goodness me. I'll try and highlight all the 9s just to be, for the sake of good order. But the start of that is to die for. It's ridiculously clever. The fact that there has to be a 9. There had to be a 9 in one of those 3 moons. And yeah, this was what sort of got me into the puzzle. I noticed the 9s in column 7 were in the same positions. But then you still have to have you know, the thought about the T and the C, the and the cryptic, because the and cryptic, it turns out, are the important pieces of the puzzle. Because there is something going on, and someone will have to tell me what this pattern is. I do not know what it is. It's sort of a weird, disjointed swordfish with a vertical component. And that vertical component gave me that digit, and that allowed me basically to solve the puzzle. I absolutely loved that. That was first class. Let me know in the comments how you got on with it. Look out tomorrow night for the streaming. Hopefully it will happen. I will tweet about it, as I say. And thanks so much for watching. And we'll be back later with another edition of Cracking the Cryptic.